Back in the 1930s, manufacturing sophistication had grown to the point where something more was needed than a powered chain that went round and round. Industry was saying, we don't want to have to stop the whole line every time we have to take something off to work on it or to store it. In the 1930s, the Jervis B. Webb Company introduced the first power and free conveyor. Instead of attaching the carrier directly to the power chain, a pusher or pusher dog was added to the power chain. A second track, a free track, was added below the power track. Into the free track went the carrying trolleys. Add a pusher assembly to the carrier and put them in motion. To stop or isolate a single carrier or group of carriers, the distance between the power track and the free track is increased. This allows the carrier to disengage from the power track. Gravity alone carried the trolley to its work destination. Thus, while the power chain kept rolling, manufacturing operations and special procedures could be performed on parts and assemblies now free of powered movement. We've had a look at basic power and free. Simply disengage the power track from the carrier riding the free track and let gravity do the rest. That was fine up to a point, but gravity doesn't give us much control. Dog magic gives us that control. Positive mechanical control over every carrier in the system. How? This is a multiple trolley dog magic carrier. The power trolley is above. The carrier rides in a free trolley below. Were we to start the power chain, the next power chain pusher dog will pick up the carrier assembly dog, moving the whole carrier forward. Another carrier at rest. And it stops. But the power chain keeps on going. That's the magic in dog magic. Let's start all over and take a closer look at that carrier. Different, isn't it? Jaws in front, a tail in the rear. Dog magic gains its magical qualities because this carrier dog is retractable. It can be retracted from the power chain pusher dog because of the action of this operating link down below. The operating link pivots up and down. It's counterweighted so that at rest it sits down. It's connected to the carrier dog. When the connecting link is at rest, the pusher assembly on top of the carrier is forced up, ready to be engaged by the next pusher dog on the power chain. Up the line waits that stationary carrier we saw earlier. Take particular note of the tail and its cammed surface. Here comes our carrier. The operating link on the moving carrier rides up the cam tail of the stationary carrier. Up goes the front. The rear of the operating link pivots downward, retracting the dog magic carrier dog into the carrier assembly away from the power chain. The carrier stops. These are the basic ingredients of dog magic. It's not really magic after all. It is the application of sound mechanical engineering principles to the science of materials handling. There are some other features of the dog magic system which enhance its materials handling effectiveness. A programmed stop, for example. Rather than riding up the cam tail of a preceding carrier, this carrier approached a stop. The stop mechanism is a mechanically or automatically operated blade which slides over the top of the free track. The leading cam surface of the carrier dog rides into the stop blade and is forced downward into the carrier assembly. Just behind the pusher dog is what is known as a holdback dog. Although it will give way or flop to pressure from the rear, it locks when force is applied from the front. With the carrier dog cammed downward, the carrier stops, held securely by the stop blade against the holdback dog. The power chain continues on its way. Withdrawal of the stop blade allows the carrier dog to return to the up position raised by the counterweighted pivoting of the operating link. The carrier moves off when it's picked up by the next power dog. And on the floor of anybody's plant, virtually anywhere in the world, watch for the operating link to drop, which shows us that the stop has been removed. There. The lead carrier moves off, under control, to the next production stop. Carrier movement from line to loop, from loop to spur, and back again is accomplished through switches and across transfers. Of particular interest is an exclusive Jervis B. Webb device known as push-across transfer. Here, one power chain loops away, another loops in. The free rail crosses from one to the other. That's the path the carrier will follow. As we look closely at the rear free trolley, we find yet another dog, low in profile. It's called, aptly enough, the push-across dog. Close to the transfer point, the vertical distance between the power track and the free track is tightened, closed, so that the next power dog may now contact that push-across dog. As the transfer is approached, the carrier rides the free track to that point in the transfer where the front chain pusher dog wipes away from the dog magic trolley. The power rail departs the free rail. The carrier stops. The front dog magic trolley of the carrier is part way through the transfer, yet not far enough through to permit pickup by its new chain pusher dog. Back on the old chain, the next chain pusher dog approaches the rear trolley. It engages the carrier push-across dog, moves the whole assembly forward. The next chain pusher dog on the new conveyor contacts the retractable dog magic trolley dog, and the entire carrier is on its new path. Let's watch it again in slow motion. Approaching the transfer. The track drop is tightened. The chain wipes away. The next chain pusher dog approaches the rear trolley of the carrier, picks up the carrier push-across dog, further through the transfer. Power dog contact. Carrier on its way. Now at normal speed. Both in theory and in fact, Dog Magic Power and Free conveyor systems introduced a completely new dimension to the imperative science of materials handling.